Okay, let's get into it. So, when we left off, we were looking at objects in JavaScript. We went through loops, we went through arrays, we started the JavaScript Java Syntax Part 2 chapter. And right now we're tackling objects. So let me see if I can remember what we were doing here. And I kind of do. So the first task was to access the captain object and pull out his specific favorite food. More specifically, the first one. And now we have to change the passenger property into an array of objects. And these objects should represent the spaceship passengers as individual objects. And we have to make at least one passenger object in the array that has at least one key value paired to it. So, before we do that, what I also want to do is open up the cheat sheet, because I do need a little bit of a refresher on objects in general. So it should be somewhere here. Right, JavaScript syntax part 2. And where is my cheat sheet? There. Right, there we go. So just as a bit of a refresher for both myself and anyone who might be watching. So the JavaScript destructuring assignment is a shorthand syntax that allows object properties to be extracted into specific variable values. It uses a pair of curly braces with property names on the left side of the assignment to extract values from the objects. The number of variables can be less than or can be less than the total properties of an object. So the shorthand property name syntax for object creation. So this is how we create an object. And as far as I remember, if an object with that name doesn't exist, one gets created. Allows creating objects without explicitly specifying the property name. Getters and setters. This we didn't go through this yet. Okay, well, so if we initiate an object like so, or rather like so, I think. Each activity equals surfing. Okay, so to sort of initiate or change the property of passengers, I suppose we simply have to access it through the spaceship. So spaceship dot passengers. And then we simply assign it an array of objects. So we have to instantiate or initialize objects ourselves. Essentially like so. So const, let's say mark, and or can do, well, okay, let's say mark, and then wait, something feels a bit off with this. You know what? Let's go back. Here, property assignment. So once we've defined an object, let's even go further back. Actually, let's go back to the beginning, because I feel like I didn't get it the first time. So let's just repeat the chapter a little bit to get a better grasp on what we're doing here. So it's time to learn more about the basic structure of that permeates nearly every aspect of JavaScript programming, and that is objects. You probably blah blah blah. There are only 7 fundamental data types in JavaScript, and 6 of those are the primitive data types. We can use JavaScript objects to model real-world things like a basketball, or we can use objects to build the data structures that make the web possible. Right, so okay. Objects can be assigned to variables just like any JavaScript type. We use curly braces to designate an object literal. So this is how we initiate an object. We fill the object with unordered data. Right, so we need to remember the syntax. So this, I guess, acts as a key. And then the following is the value. No. This is an object itself. And these are the keys, and these are the values and properties. Right. Okay. So then to access these properties, we simply place a dot. Yeah, that I remember. But then to access the value, access the value of numCrew from the spaceship. So that would be, okay, so the other way around, if we wrote equals here and then change it to something, that will change it. So it works as I expected. The bracket notation, yeah, that's for properties that have these double character or double worded names. That I do remember. Okay, and we just access that with the assignment operator, and we can change it like that. All right. and then the methods are written as simply method name, parentheses, and square brackets. All right. Okay, so going back to this, I'm fairly certain that the beginning was correct, because that's how we access the passengers. And then we want to change the passengers value, so we simply do this. And we assign it as an array of objects. These objects should represent spaceship passengers as individual objects. So we can simply do like so. Make at least one passenger object in the array that has at least one key value pair on it. So let's say passenger 1, and we simply do like so, and then we say first name equals Mark, right? And then comma, we can do last name equals, I don't know, Wazowski. So that should be correct. No. Unexpected token. Maybe we don't need this here. Still not correct. Oh, because we used an equal instead of the proper thing. Like this. Still no. But it assigned it. Okay, well, we have one object, make at least one passenger object in the array that has at least one key value pair on it. Well, it does. It has two. Let's look at their solution. Wait a second. Oh, so they assigned it here. And then they accessed it through here. Oh, wait, no. They accessed it through here. Oh, that's okay. That's just a bit of, like, that's just confusing wording. Like, we're supposed to write it here. So it's an array. Where we do... I already forgot how we created the first one. Right, we do array, and we say passenger 1 equals to so first name let's say Mark, and then last name Wazowski. Right, and then we access him the same way we accessed the captain's Fave stuff. So passenger 1 equals spaceship dot passengers and the first one. No. Passenger 1 is not defined. But you don't need to define it like that. So I guess you just don't need that. And then it should work. Yeah. Okay, so within an object, the parameters are... But this is not... Because the instructions said, instead, assign its value an array of objects. But these are not objects. They're just parameters. Oh, I mean properties of the passenger. Okay, let's take a look, actually, what we will get if we print out passenger 1. Okay, so we got this entire thing. And if we add to it, it's not gonna be a separate object thing. Wait. Unexpected identifier. And this is odd. Oh, we just forgot a comma. Oh, so this was rewritten. Mark was changed to Josh because we just updated the variable. But if I have, say, age, 29, yes, then we get back that parameter as well. However, what if we were to add a comma and say instantiate another passenger? Let's say Josh. Bluebaum. and then print out. Right, so this will be passenger 1, and we print out the second thing. Okay, so Josh Bluebam. And what if we just assign all the passengers to that value? Right, we get back all of them. Okay. I mean, I sort of understand it. But then again, it's kind of confusing at the same time. All right, let's do the third one. So it's supposed to be 0. Create a variable, first passenger, and assign the first parameter as its value. Make sure to use bracket and dot notation to get the passenger object through the nested access. So that's what we did. No. Create a variable, first passenger. Oh. Yeah. That's how you access it. Okay, well, let's move on. It's a little bit confusing, but I'm sure with some practice, we'll get it. We'll get there. Pass by reference. Objects are passed by reference. This means when we pass a variable assigned to an object into a function as an argument, the computer interprets the parameter name as pointing to the space in memory holding that object. As a result, functions which change object properties can actually mutate the object permanently, even when the object is assigned to a const variable. Okay. So we pass the object, and we can access its parameters through the passed-in variable. All right, that's fairly standard. Our function painted permanently changed the color of our spaceship object. However, reassignment of the spaceship variable wouldn't work in the same way. Right, so if we try to reassign it through the object variable, it will sort of pretend like it's reassigning it, because if we print it here, in essence, from what I'm understanding, it becomes a separate object, but the original one has not been modified, because it still returns home planet Earth color red. But regular assignment outside of the function still works. Okay. So we declare the spaceship object with let. Yes. This allowed us to reassign it to a new object with identified and transport type properties with no problems. Reassign it to a new object. Spaceship. But is this... I still don't understand, like, what does this do in terms of the spaceship? Does it add these parameters? Properties, I mean. So when we try the same thing using a function designed to reassign the object passed into it, the reassignment didn't stick, even though calling constant log on the object produced the expected result. When we passed spaceship into that function, object became a reference to the memory location of the spaceship object, but not the spaceship variable. This is because the object parameter of the try reassignment function is a variable in its own right. Right. So the body of try reassignment has no knowledge of the spaceship variable at all. When we did the reassignment in the body of try reassignment, the object variable came to reference to the memory location of the object, identified false, transfer type flying, while the spaceship variable was completely unchanged from its earlier value. Right, because... okay, I'm sort of getting it. So let's write a function, green energy, that has an object as a parameter and sets that object's fuel type property to avocado oil. So const green energy equals object, and we set the object dot object fuel type equals avocado oil. Correct? Correct. Then write a function, remotely disabled, that has an object as a parameter and sets or reassigns that object's disabled properly to true. All right. Wait, what? Oh, remotely disable, not disabled. Call your two functions with the spaceship object in the code editor, then console log the spaceship object to confirm those properties were changed or added. So we want to call green energy with the spaceship object. Correct? Correct. And then we also need to remotely disable with the spaceship object as well. And then we console log the spaceship. So, okay, we reassigned it. Wait, so what was all of this about? The reassignment not working the same way. Oh, so we can change values, but we cannot change the properties themselves, or property names rather. That's what I'm kind of getting here. Whereas in outside of function, we can actually add or change the property names. Okay. So looping through objects. Loops are programming tools that repeat a block of code until a condition is met. We learned how to iterate through arrays using their numerical indexing. The key value pairs in objects aren't ordered. JavaScript has given us alternative solutions for iterating through objects with the for in syntax. Okay, so we have to remember 3 different syntaxes for loops. So just normal for loops, then for of, and then now for in. So for in will execute a given block of code for each property in an object. Our for in, let crew member in spaceship crew, will iterate through each element of the spaceship crew object. In each iteration, the variable crew member is set to one of spaceship crew keys, enabling us to log a list of crew members' roles and name. Okay, so using for in, iterate through the spaceship crew object in the code editor and console log a list of crew roles and names in the following format. All right, so for let say crew member in spaceship crew we simply console log crew member's role crew member dot role and name. Something seems a bit off, but oh, I used a percentage sign here instead of the correct sign. Crew member role and crew member name. No, it's not happy about something. What? Could not find crew member. Did you mean crew member? Oh, member. I wrote member. Undefined, undefined. Huh. Oh, we need spaceship too. No, we don't. We're accessing already the crew member. Wait, so maybe we don't even need crew member here. We just directly access the role and the name. Hmm. Or do we just crew member and then crew member dot name? Right, so we accessed the crew member, but here undefined, undefined. I mean, that should be how you access the names. Name. Okay, crew member. Just name? No, doesn't make sense. Crew member dot name. Hmm. Let's see. Wait, what? Spaceship crew. Crew member name. Why do we have to access it that way when we already have access to the crew member? Like, what? Spaceship dot crew. Crew member. Then dot name. Holy cow, this is weird. Okay, fine. Spaceship dot crew. Then we do crew member. And then dot name. Yeah. Okay, this is logic is wild. To me at least, I don't know. Because we have to all over again access the spaceship crew object. Or the parameter. And then from it, we have to assign which of the crew members we're accessing, and then its name. So it's not really iterating through the objects. So it's just iterating through strings of keys, and that's it. Not through the parameters themselves. Because we then can't really do anything with this crew member, except for just printing it out. take a look at this link. What do they have here? Property. So for property in object. Iterates over all enumerable string properties of an object, ignoring properties keyed by symbols. Okay. So in this case, where our property is a bunch of other objects, it doesn't really iterate through the objects. Or through these. No, wait, I'm getting lost here. We're iterating through spaceship's crew properties, which is captain, chief of officer, medic, and translator. And then for each one, we just print out the name. Okay, maybe it's because it's Monday. Maybe it's because, I don't know. I'm just a little bit slow on the uptake. But this doesn't make much sense to me. Let's move on. Using for-in, iterate through the spaceship crew object in the code editor and console log a list of crew names and degrees. Okay, so it's essentially the same thing. So for let crew member in spaceship crew, we want a console log the crew member's name, so crew member, and their degree. So spaceship dot crew member dot degree. Right. I mean, it's the same thing. What do you mean it's not correct? Degree. Oh, crew member's name. Okay. A little bit slow today. Spaceship dot crew. So, crew member dot name. No. Oh, it's just like so. Dot name. I'm still in the dark as to why we have to include the crew member variable into square brackets, but you know, okay. All right. Way to go! You're well on your way to understand the mechanics of objects in JavaScript. By building your own objects, you will have a better understanding of how JavaScript built-in objects work as well. You can also start imagining organizing your code into objects and modeling real-world things in code. So objects store collections of key-value pairs. Each key-value pair is a property. When a property is a function, it is known as a method. An object literal is composed of comma-separated key-value pairs surrounded by curly braces. You can access, add, or edit a property within an object by using dot notation or bracket notation. We can add methods to our object literals using key-value syntax with anonymous function expressions as values, or by using the new ES6 method syntax. We can navigate complex nested objects by chaining operators. Objects are mutable. We can change their properties even when they're declared with const. Objects are passed by reference. When we make changes to an object passed into the function, those changes are permanent. We can iterate through objects using the for in syntax. Okay. Quiz time. No, it's not. Advanced object introduction. Oh my god. Advanced objects. Alright. Remember, objects in JavaScript are containers that store data and functionality. In this lesson, we will build upon the fundamentals of creating objects and explore some advanced concepts. So if there are no objections, let's learn more about objects. So in this lesson, we will cover these topics: how to use this keyword, conveying privacy in JavaScript methods, defining getters and setters in objects, creating factory functions, and using destructuring techniques. All right, let's look over the code and see examples of the objects-related concepts covered in the lesson. Well, could have left some comments, because I don't know what I'm looking at. Okay, so we have an object with two properties and a method. Then we have a function that takes in the model and mobile parameters and does what? Just creates an object. Is that what this is? Yes. Oh, this is a function to create an object. To initialize an object, in a sense. And then assigns it to a value. New shiny robot. Okay. Then we have another object. Charging station. And what is set and what is get? That's, I recognize these from Python. These are private sort of parameters or properties, private properties. that you cannot access from with that notation. Okay, let's move on. So objects are collections of related data and functionality. We store that functionality in methods on our objects. Right. In our goat object, we have a makeSound method. We can invoke the makeSound method on goat. Yes. Goat makeSound. Nice. We have a goat object that can print ba to the console. Everything seems to be working fine. What if we wanted to add a new method to our goat object called diet that prints the goat's diet type? Right, so we diet and so reference error, diet type is not defined. So we can't access the parameters, properties, I mean, from within the object. Oh, this is going to be like the self thing, isn't it? That's because inside the scope of the diet method, we don't automatically have access to other properties in the goat object. Here's where this keyword comes to the rescue. If we change the diet method to use this, right. Okay, so except whereas in Python you have to reinitialize the properties with self, here it sort of is implied, and then you just access it with this diet type because this stands for this object. Okay, so this keyword references the calling object, which provides access to the calling object's properties. In the example above, the calling object is goat, and by using this, we're accessing the goat object itself and then the diet type property of goat by using property.notation. Roger that. So let's create a new object and to practice using this. There is an object, robot, and let's add a property of model and assign it, just assign it like this, model value of 1E78, B2, and another property, energy level 100. Okay, so inside the robot object, add a method named provide info. So we just type it in, right? Provide info, and like so. Yeah. Okay, so provide info, and we need to console log return the following string by using interpolation. I'm a model and my current energy level is at blank. So console.log I am this.model and my current energy level is this dot energy level. No. Provide info. Unexpected identifier. Wait, did I? So this corresponds to this. And then this with this and this with this. So what's wrong? Provide info. Oh, commas are missing. Yeah. And then we can add a comma here as well. No. I am model, and my current energy level is energy level. Probably a dot missing there. Nope. Oh, we don't console log it, we return it. There we go. And now we check by, now to check, provide info has access to the internal properties of robot. Log the result of calling provide info method on robot to the console. So robot dot provide info to the console. Wait, that's just console log. Okay. All right, that's fairly straightforward. Arrow functions and this. So we saw in the previous exercise that for a method, the calling object is the object the method belongs. Right. If we use this keyword in the method, then the value of this is the calling object. However, it becomes a bit more complicated when we start using arrow functions for methods. How so? So that's a normal function, that's an arrow function. In the comment, you can see that dyad prints undefined. Arrow functions inherently bind or tie an already defined this value to the function itself. That is not the calling object. I see. So in the code snippet above, the value of this is the global object, or an object that exists in the global scope which doesn't have the dyad type property, and therefore returns undefined. Okay, so the key takeaway from this is we have to avoid using arrow functions when using this in a method. Okay, so currently the check energy method is not producing the correct output because it is using arrow function syntax. Refactor or change the method to use a function expression. You can write the function using either longhand or shorthand format. After refactoring the method, notice that checkEnergy has access to other internal properties of the robot object. So we just delete this and delete this. Correct? Correct. Privacy. Accessing and updating properties is fundamental in working with objects. However, there are cases in which we don't want other code simply accessing and updating the object's properties. When discussing privacy in objects, we define it as the idea that only certain properties should be mutable or able to change in a value. Certain languages have privacy built in for objects, but JavaScript does not have this feature. Rather, JavaScript developers follow naming conventions that signal to other developers how to interact with a property. One common convention is to place an underscore before the name of a property to mean that the property should not be altered. Okay, so it's not like built in, it's just like a convention. So you can still access and change the property, but you're just not meant to. Right, even so, it's still possible to reassign a mount. In later exercises, we'll cover the use of methods called getter and setters, but both methods are used to respect the intention of properties prepended or began with underscore. Getters can return the value of internal properties, and setters can safely reassign property values. For now, let's see what happens if we can change properties that don't have setters or getters. So below the robot object, reassign the energy level property to high. Okay, robot dot energy level equals high. No, not the right kind of high. Now take a look at the new recharge method in robot. So recharge will add 30 to energy level. But it isn't a number now. So let's call robot.recharge. It's currently at high 30%. Yeah. Okay. All right. Let's take a quick break. Stretch legs, drink some water, make a cup of tea, make a cup of coffee, hit the bathroom. We will be back in 10.